Okay, in this question we're working with reflections. The reflection is going to be of, after we sketch, y equals x squared plus 3x minus 4. What we've got to do is show the intercepts, the x-intercepts, the vertex, the point, the bend, the turning point, then reflect it about the x-axis. What are we going to do? We're going to reflect it about the x-axis. Now, the first thing we're going to do is sketch this, then we're going to sketch the reflection of this about the x-axis. How do you find the reflection about the x-axis? Very simple. What you do is you use this rule down here. You reflect about the x-axis. All you have to do is replace y by negative y. What do? You replace y by negative y. So the way we're going to do this, first of all, is write down function x, which is what we have here. So that's function x. So function x is equal to x squared plus 3x minus 4. Okay, that's our function x. What we're going to do is we're going to find the intercepts and the vertex and then reflect it. Now to reflect it, we need to find function negative x. Function negative x is going to be the reflection. It's going to be negative function negative x. Negative function, because we're replacing y for negative y. So that means it's going to equal negative whatever we have here, which is x squared plus 3x minus 4. All that's got a negative right in front of it. So negative function x equals negative all of this function over here. So we're going to do that in a moment. That's the reflection about the x-axis. Let's work with this, which is the function we're going to start off with, which is what we've been given. So let's find the x-intercepts. Now to find the x-intercepts, y must equal 0, because y equals 0 is the x-axis. So let's make that equal 0. So that means we're going to have x squared plus 3x minus 4 equaling 0. Now we can factor this. We can factor it, x using the cross method. And we need two numbers that multiply to give me negative 4. So I'm going to give it a positive 4 and a negative 1. Now 4 minus 1 will give me positive 3, so that works. And 4 times minus 1, that gives me negative 4. So that's a good way to factorize it. So that's going to end up becoming x plus 4 and x minus 1 equaling 0. Which means we take the opposite of these signs. X plus 4 equals 0. So that means x equals minus 4. That's one of the x-intercepts. And the opposite of that, x minus 1 equals 0, means x equals 1. So the 2 points, the 2 x-intercepts we're going to be focusing on this graph is going to be here at x equals negative 4 and x equals positive 1, which is right there. So there are our 2 points. Now we've got the x-intercepts. Let's find the vertex. Now how do you find the vertex between negative 4 and 1? Well, all you have to do is count to the middle. Now there are 5 units between 1 and negative 4. Half of 5 is 1.5. So you go 1.5 any way you want. I'm going to go left 1.5, 1.5, which is, let's see now, sorry, 2.5. Half of 5 is 2.5. So we're going to go in 2.5. 1, 2.5. is right there at negative 1.5. So that means when x equals negative 1.5, which equals negative 3 on 2. I like to put it as an improper fraction. It's easier to work with. So we're going to work with that now. I'm going to take that, negative 3 on 2, and substitute it into the original function. What's that going to do? Because if I substitute that point into the function, it's going to tell me the y component, so I know if it's down the bottom or at the top or where it's going to be located, that vertex. So let's substitute x equals negative 3 on 2 into the function x squared plus 3x minus 4. So let's take it, slide it in there. So function negative 3 on 2 is equal to negative 3 on 2 all squared, negative 3 on 2 all squared, plus 3 times 3 on 2, negative 3 on 2 actually, negative 3 on 2 minus 4. Okay, let's further simplify this. That's going to equal negative 3 on 2 times negative 3 on 2 is positive 9 on 4 minus, because a positive and a negative is a minus, 3 3s are 9 on 2. Let's check that. 9 on 4 minus 9 on 2. Bring down the minus 4. Minus 4. What's that going to equal? So on your calculator, 9 on 4 minus 9 on 2 minus 4. That's going to give you, as you work it out, it's going to give you a negative number. It's going to be negative 6 1/4. Negative 6 1/4. All right, negative 6 1/4. When is it going to be negative 6 1/4? When x equals negative 3 on 2. Y is going to be negative 6 1/4. So let me write down those coordinates. I'll just write them down over here. We got negative 3 on 2. When we got negative 3 on 2 or negative 1.5, we're going to have negative 6 1/4. So let's go ahead and put these points in. Negative 1 1/2 there, down negative 6 1/4 is right over there. So if we join the dots between the x-intercepts at negative 4 and positive 1, let me just join the dots. Now there's one more thing we can focus on, and that's where it cuts the y-axis. It cuts the y-axis when x equals 0. So when x equals 0, it is the y-axis, so it's going to cut at negative 4. How do we know? Because if I put 0 in there, x equals 0, in other words the y-axis, 0 squared plus 3 times 0 minus 4, we're left with minus 4. There's our minus 4, so it also goes through there. So we've got the y-intercept, the two x-intercepts, and down here, the vertex. So let's join the dots. So that's going to be there we go. That's our function x. That's function x is equal to x squared plus 3x minus 4. Minus 4. There it is right there. The two x-intercepts, the middle vertex, right through that, negative 1.5, and down the bottom right here, at this point over here, we have that point, that's minus 6 1/4. So I'll just put that vertex there. The vertex is negative 3 on 2, negative 6 1/4. Negative 3 on 2, it's a bit messy. Minus 6 1/4. There we go. All right, that's our vertex down there. That's our parabola, the first function. Now let's reflect it about the x-axis. So this is going to reflect that way. It's going to reflect up. So it's going to overlap up here somewhere. So let's go ahead and do that. But first I'm going to just mark out some of the points. Goes through there, and that goes through there, right there, and it actually cuts at negative 4, right over there. So those points are marked out. Okay, now what we're going to do now is reflect this upwards like that across the x-axis. So the reflection is happening about the x-axis, right? So we're going to get a parabola coming concave down like that. So in order for us to do this, we're going to write down, what we're going to write down, y for negative y. So we're looking for function x equals negative x squared plus 3x minus 4. So in order for us to do this, there's a negative in front of there. So I'm going to keep that negative. Negative function x is equal to negative x squared plus 3x minus 4, which means I'm going to use the same numbers, x and x, to factor that. It's going to be 4 and 1, positive 4 minus 1, so it's going to be x plus 4, x minus 1 equals 0. And there's a minus in the front, just ignore that for now. So x equals negative 4 and x equals positive 1. Now you'll see those two x-intercepts are identical, exactly the same as the previous one, negative 4 and positive 1. Negative 4, positive 1, exactly the same. Nothing's changed. So the same x-intercepts. Now, where does this cut through on the y-axis? The y-axis, where does it cut? Well, we need to expand this. So if I was to expand it and bring the negative 1 times x squared, negative 1 times 3x, negative 1 times minus 4, what's going to happen is that's all going to change sign, and it's going to become negative x squared minus 3x plus 4, because we've got a negative and a negative, plus 4. So that's what negative function x equals, right? So we want to find now the next intercept. The intercept we want to find now, besides the x ones, is the y-intercept. Where does it cut the y-intercept? Well, it cuts the y-intercept when what? When x equals 0. So when x equals 0, and I put 0 in here, 0 squared minus 3 times 0 is 0, plus 4 equals 4. So that means y equals 4 on the y-intercept. That's the y-intercept on 4. It's going to cut through there, right there, positive 4. Okay, so we've got these two intercepts. We've got positive 4, the two intercepts, positive 4. The next thing we need to do is find that vertex. The vertex is going to be up there somewhere. Let's find the vertex V. So vertex, let me just put a bit of a boundary here. Let's find the vertex. Vertex V is going to be that point up there as I indicated. So it's going to be at the same middle point here between negative 4 and 1. It's 5 units across. You count 2.5 for the middle. So 1, 2.5 is going to be negative 1.5, which is the same as negative 3 on 2. So that means the x component equals negative 3 on 2, just like before. It's the exact same axis of symmetry right through the middle. Now if x equals negative 3 on 2, all we have to do is substitute it into this equation right over here. Negative x squared minus 3x plus 4. Let's take it and substitute it right in there so we can find exactly that point up there, that vertex, the y component of the vertex. So let's put it in there. So y is going to equal negative 3 on negative, and then we put in negative 3 on 2 all squared. Be careful about that. You already got a negative here. Where's that negative? See that negative? That goes there, and negative 3 on 2 goes in. So we've got two negatives. And then we've got minus 3, let me create some space there, minus 3 times x, which is 3 on 2. And then what do we have? Plus 4. Now I can put a little box around there. There we go. Let's start to simplify this. We've got y equals negative times this. Now this squared is going to give us a minus, 3 3s are 9 on 4. So 3 on 2 negative squared is 9 on 4. Just bring down the negative in front. Next, it's going to be a minus times a positive. Oh, wait a minute, that's a minus 3 on 2, isn't it? That's a minus there. A negative and a negative, that's going to give us a positive, isn't it? Two negatives, so that means that's going to be 3 3s are 9 plus 9 on 2 plus 4. Okay, negative 9 on 4 plus 9 on 2 plus 4. Very good, very good. So that means we've got y equals, put that through your calculator, negative 9 on 4 plus 9 on 2 plus 4 all together. That's going to give you a value. It's going to be positive. It's going to be 25 on 4, which equals, as a proper fraction, 6 1/4. So it's the exact reverse of this. It's positive 6 1/4 up there. So y equals 6 1/4. So the vertex again, I'm going to write it down. There's our vertex. We've got the x component and we've got the y component. That's our y component. So our vertex V. for the reflected function up here like that, for negative function x, is the vertex is negative 3 on 2 and positive 6 1/4 or 6 1/4. There's our vertex. So let's mark it out up there on the diagram. Minus 3 on 2, minus 3 on 2, up 6 1/4, up 6 1/4. That's going to give us a point right over there. Goes through 4, goes through these 2 points, so let's just join the dots. So it's going to go like that, like that, like that. And it's going to go like that. So here's negative function x, which equals negative function x equals negative x squared. Let me just move this over to the left. Which equals negative x squared minus 3x plus 4 minus x squared minus 3x plus 4 minus x squared minus 3x plus 4. That is negative function x, negative function there, and that's right there. It's negative, and that's also an error right there. So there it is right there. Now you'll see that we got the original function x in red, and then we reflected it about the x-axis, so it mirrors straight up there, flipped up there, and we got the reverse of it, negative function x equals negative x squared minus 3x plus 4.